Okay, first write it down up to here. So this is what types of intermolecular force of attraction. Okay, depending on the nature of the molecules, right? Depending on the nature of the molecules, depending on the nature of the molecules, they can be classified as. While writing, we'll just write two lines, but that's all. Okay, but because you understood that, right? Okay, they can be classified as number one or number A, dipole hyphen dipole, dipole interaction, dipole interaction. Right. When both the molecules interacting are polar in nature, okay, they are called, I mean, they means the force of attraction is called, right? The force of attraction is called dipole interaction. Dipole interaction. Okay. Number 2 or number B, ion dipole interaction. If the force of attraction is between a polar molecule and an ion, comma, it is called ion dipole interaction. Number 3, whatever you are writing. Okay, third one, that is ion induced dipole interaction. Ion induced dipole interaction. Dipole induced dipole interaction. Dipole induced dipole interaction. Right. If the force of attraction is between a polar molecule and a non-polar molecule, if the force of attraction is between a polar molecule and a non-polar molecule, comma, where the non-polar molecule gains the dipole moment because of the induction, comma, it is called dipole induced dipole interaction. I hope all of you understood that, right? Okay, what is that? You understood. The concept is clear. Okay, because it's not that we have to know the examples. The examples will automatically come when we will study. Okay, fine. So that is called dipole induced dipole interaction. Number 4, London's force of attraction or Van der Waals force of attraction. Okay, right. This is a temporary or momentary. Force of attraction because of the momentary position of the electrons present in the substance. Momentary position of the electrons present in the substance. Okay, full stop. Got it? Okay. Out of all the above four intermolecular forces of attraction, out of all the above four intermolecular forces of attraction, out of all the above four intermolecular forces of attraction, comma, the strongest one is dipole-dipole interaction, and the weakest one is van der Waals force of attraction, right? The weakest one is van der Waals force of attraction. Okay, van der Waals force of attraction. Fine. Okay. Next line you write. There is a special type of dipole-dipole interaction. There is a special type of dipole-dipole interaction, comma, which is known as H bonding, that is hydrogen bonding, right? H bonding, right? Hydrogen bonding. Full stop. The molecules which exhibit this type of intermolecular force of attraction must yes.
So can you please repeat once? Your network.
The molecules which will exhibit this type of intermolecular force of
So
attraction
can you repeat from
known as hydrogen bonding, H bonding, hydrogen bonding. Okay. The molecules which exhibit this type of intermolecular force of attractions, the molecules which exhibit this type of intermolecular force of attraction must number one have hydrogen in it. Must have hydrogen in it. That is the first one, right? Okay. And number two, what is number two? The hydrogen present, the hydrogen atom present, H atom present, must be directly bonded with F or O or N, right? Fluorine or oxygen or nitrogen, as they are the maximum electronegative elements. They are the maximum electronegative elements. Okay, full stop. In that only you write the hydrogen bonding. First you write, then I am explaining simultaneously. Okay, the hydrogen bonding can be further classified. The hydrogen bonding can be further classified as two types. The hydrogen bonding can be further classified in two types. Number A, you write intermolecular hydrogen bonding. Intermolecular hydrogen bonding. What is intermolecular? You know this difference. Inter-school tournament. What do you mean by inter-school tournament? Inter-school tournament means in between the schools, right? With one school to the other school, right? Intermolecular. Same way, intermolecular hydrogen bonding means between the two molecules. Between the two molecules, right? That molecules can be same, that molecules can be different also. The molecules can be same, molecules can be different, but if it is between the two molecules, then we call it, suppose, Anna, give you a hand. Now suppose if we are bonded, I am one substance, she is one substance, we are bonded. That is called intermolecular bond. Yes, between the two substances. It can be same also, it can be different also. Is it clear? That is intermolecular. But suppose my hand, two hands are bonded like this. Okay? Now the bonding is within me only. I am the substance and the bonding is within me only. Then it is called intramolecular hydrogen bonding, right? You understood that? Intermolecular means between the two molecules same or different, and the intramolecular means inside the molecule only the hydrogen bonding is there. Okay? These are the two types of hydrogen bonding that can be classified as. Okay? So first is intermolecular hydrogen bonding. For example, right, intermolecular hydrogen bonding. What, you wrote down the definition? Okay, you wrote down. For example, right? For example, H, O, H. You know this? This is delta negative, delta positive, delta positive. Another, right? H, O, H. Okay? This delta negative, delta positive, right? Okay? And there is a kind of force of attraction between them. Generally, we represent by dots. Generally, we represent by dots in between. Okay? Dotted lines. Fine? Okay? So, this is what type of force of attraction, you tell me? This is one molecule. Yes? This is another molecule. So, the force of attraction is between two molecules. Yes? In this case, it is same. It might be different. Clear? Okay? Then the molecular force of attraction is known as what? Obviously, this is hydrogen bonding. Why hydrogen bonding? Now, if I ask you why hydrogen bonding, can you explain me? Why hydrogen bonding? Because the molecule has hydrogen. First point. Just 2 points has to be followed. The molecule has hydrogen, and that hydrogen is directly bonded to the oxygen. It must be directly. So, if I ask you now, will HF show the hydrogen bonding? Tell me, will HF show the hydrogen bonding? Yes, because H is bonded with F. But if I ask you, will CH4 show the hydrogen bonding? No. You understood that? So just by seeing this or knowing the structure of the molecule, you can say very easily that which molecule will show the hydrogen bonding, which won't. Yes, it's not that hydrogen hone se hi hydrogen bonding hoga. There is always a second condition which has to be checked. Clear? Number 2 or number B. Okay? Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Intramolecular hydrogen bonding. That's number B. Intramolecular hydrogen bonding. Okay? Right. If the hydrogen bonding is seen, inside the molecule, then it is called intramolecular hydrogen bonding. Intramolecular hydrogen bonding. Just for example, at this moment, you don't know this compound. I'm just drawing it. You also draw it simultaneously, and they'll write down the name, because sometimes, since it may come in your exam also, that write down an example where it shows the intramolecular hydrogen bonding. So just you write down this, okay, and then you write down the name. First, I hope all of you know the structure of the benzene ring. Yes? Okay, double bonded in the alternate positions. Okay, just draw it with me. Benzene ring. Okay, then here you write OH. Here bond O, bond H. Okay, All these we are going to understand afterwards only, not now, not even in class 11. Class 11 little bit, okay. And here you write N, arrow O means a coordinate bond, okay, double bond O. This is coordinate bond, you know this, okay. Arrow, when we use arrow, you know this, coordinate bond, okay, and double bond O. The name of this is, you write down the name of this compound, then I am showing the hydrogen bonding. So this is the compound, one compound only, and the name of this compound is ortho-nitrophenol. Ortho-nitrophenol, PAGNOL, okay, ortho-nitrophenol, okay. Please draw it properly, don't draw like anything, okay, because it is not that you cannot draw it like this. So now tell me, first question I am asking you, will it show the hydrogen bonding? Yes. Why? There is more hydrogen, but one hydrogen is there which is bonded with oxygen, directly bonded with oxygen. So obviously this will be delta negative, this will be delta positive, that we know. Yes. Okay, and the high charge is there. Yes, high charge difference is there. Now here you see, in between nitrogen and oxygen, the coordinate bond is there. What is the meaning of coordinate bond? I am giving my electron to share. Means I am almost losing my electron. I am almost losing my electron. Means this nitrogen is almost losing its electron towards this oxygen, right? Okay, and it is giving for the share. So this oxygen is what? This oxygen is delta negative. I am not writing about nitrogen. Okay, this oxygen is delta negative. Now there will be a force of attraction, as I told. मेरे ही दोनों हाथ के बीच में force of attraction है. मेरे ही दोनों हाथ के बीच में force of attraction है. So now there will be a force of attraction generated between this hydrogen and this oxygen. Will there be a force of attraction that will be generated? समझ गया बात? Yes, they are close to each other, so there will be a generation of force of attraction between these two atoms present inside the molecule itself. Okay, and that type of hydrogen bonding is called what? That type of hydrogen bonding is called intramolecular hydrogen bonding. Okay, so what is intramolecular hydrogen bonding? You understood that. First point is that. Okay, and if the question comes that give an example where we can see the intramolecular hydrogen bonding, you can write it down what? You can write it down that it is ortho-nitrophenol, and just practice little bit this structure so that you can understand it. Right? Yes? Yes, done? Okay, so this is actually what I taught is that the nature of the intermolecular forces of attraction till now. So just let us recap that what did we study? That matter can be of three types, all of us know this: solids, liquids and gases. Yes? Out of that, as I told, that the solids and the liquids we are going to study in class 12, we are going to mainly study the gases. Now why some substance is solid, why some substance is gas, why some substance is liquid? That is determined by two factors. What are the two factors? One is intermolecular space. सब पता है आप लोगों को ये सब. Intermolecular space, if it is less, it is solid. If the intermolecular space is high, it is gas. If the intermolecular space is moderate, it is liquid. Moderate means neither very low nor very high. Yes, okay. Next, who is determining that intermolecular space? It's the intermolecular force of attraction. If the force of attraction is more, then the intermolecular force will be less. Space will be less. Okay. If the force of attraction is less, intermolecular space will be more. Yes. Okay. So these are the two factors actually which is governing the total thing. And because of the states, they are showing the different properties. That properties all of us know, so I am not going into that. If I ask you what is the difference between a solid and liquid, all of you know this, so that is not our business. Now, the next thing what we did is that what is the intermolecular force of attraction? What kind of intermolecular force of attraction can be there in the substances? So there can be different types of intermolecular forces of attraction depending on what? Depending on the nature of the substance, structure of the substance. क्या क्या हो सकता है? Dipole-dipole interaction. Hope you understood that. Dipole-induced dipole interaction. You understood that. Ion-dipole interaction. You understood that. Van der Waals force of attraction or London force of attraction. That's the weakest one. Out of these four, dipole-dipole is maximum. Van der Waals force is the least. A special type of dipole-dipole interaction is there. That is the strongest. And what is that? That is hydrogen bonding. Why strongest? क्योंकि इलेक्ट्रोनेगेटिविटी डिफरेंस बहुत ज्यादा है वहाँ पे. डाइपोल डाइपोल इंटरेक्शन स्ट्रॉन्गेस्ट है, इस पे सबसे ज्यादा स्ट्रॉन्ग हाइड्रोजन बॉन्डिंग है. Why? Because the intermolecular what is that called? The electronegativity difference is very, very high. The charge separation is very, very high. Okay? Okay? So hydrogen bonding can be of two types. What are the two types? Bolo? Intermolecular hydrogen bonding and intramolecular hydrogen bonding. Intermolecular means between the molecules. Between the molecules, when I am saying, it is not necessary that it has to be one type of molecule. It can be two different types of molecules attracting with the hydrogen bonding. That also will be called the intermolecular hydrogen bonding. And the intramolecular hydrogen bonding is what? When the hydrogen bonding is inside the molecule, as I told, by two hands. I hope it is clear. Okay. Next is, we are going to study, the different gas laws. The different gas laws. As I told, we are going to study mainly the gases. Okay. Mainly, only the gases, I should say. Okay. So different gas laws. These also ICC students little bit you know already. But anyway, we have to recap little bit and we have to brush up your concepts. Now see, gas laws, there are so many gas laws. We have heard about this, Boyle's law, Charles' law, this, that, you know it, okay? But you will see that little bit something here and there will come where your concept is a little bit, brushing up is needed, okay? Maybe you studied in a different manner. Now we have CBSE students who didn't even study also these things. So you have to know this. But the first thing, let me tell you, the property of a gas, the properties of any gas does depend on four factors. The properties, any properties, physical, chemical, anything, mainly physical. It depends on four factors, four physical factors. Can anybody tell me what are the four physical factors on which the properties of the gases depend? This property, yes, temperature, fine, temperature.
Pressure, volume, temperature.
3 हो गया और pressure, volume, temperature. I told four. Yes, pressure, volume, temperature is absolutely correct. Pressure, volume, temperature, and what is the fourth one? Okay.
Amount of gas.
Yes, amount of gas. Okay. If I talk about a gas, mass of a gas, if I give you 1 mole, whatever is the mass, if I give you 2 mole, the mass will be doubled, right? Okay. Yes or not? So it is depending on four factors. The properties, any properties of the gases are depending on four factors. What are the factors? Temperature, pressure, volume, and amount. And unit of amount is nothing but number of moles. Unit of amount is what? Now we are not going to say anymore gram or kg or quintal. Okay? Unit of amount, SI unit of amount is what? That is number of moles. Okay? So it is depending on these four factors. Now, how do the properties depend on these four factors? Is governed by or governed in certain laws. Okay? In certain laws, which are called the gases laws. Okay? Which are called the law of gases. The first one of them is Boyle's law. First one of them is Boyle's law. E-L or L-E-L-E, I think. Boyle's law. Just check the spelling, okay? Boyle's law. Okay, the first one of them is Boyle's law. देखो ना भाई हमको क्या
और लॉक क्या है आपका?
कोई लॉक नहीं है, ऐसे ही खोलेगा. So Boyle's law, the first one is Boyle's law. Okay, now what is Boyle's law? Boyle's law tells, or Boyle actually experimented with the fact that how does the gas or how does the properties of the gas depend on pressure and volume? How does the properties of the gases depend on pressure and volume? Then what about this? He kept these two things constant. He didn't change the temperature while experimenting. He didn't change the number of moles, that is amount, while experimenting. Okay? And he found, see, it's very simple. Now if we think, it's very simple. Suppose some gas is kept in a cylinder and we are increasing the pressure without changing the temperature and amount. If we increase the pressure on the cylinder, what will happen to the volume? The volume will decrease. That is what is Boyle's law. So what did Boyle say? He said that the volume is the, you don't write, first you listen to me. So what did he say? That pressure and volume are actually inversely proportional to each other. Pressure and volume are inversely proportional to each other, but provided the other two factors must kept constant. Must kept constant. Yes? Okay? Physical concept, if it is clear, mathematical part is nothing. That is very simple. Okay? We are not doing mathematics class over here. So physics, the physical part of it, the conceptual part of it should be very, very clear. The visualization should be very, very clear. Okay? So that's the first law, which is known as Boyle's law. Now write. Okay? What is the heading you write? Gas, law of gases or gases law, whatever you wrote. Okay? So write the different properties of gases. The different properties of gases depend on four parameters, comma, namely pressure, volume, temperature and number of moles. Okay, namely pressure, volume, temperature and number of moles. Okay, full stop. The properties of the gases are explained by different laws, different gas laws. The properties of the gases are explained by different gas laws, and this is called properties of the laws are explained by different gas laws, and these are number one, you write. These are number one, right? Boyle's law. Okay, it states that the volume is inverse volume of a gas is, it states that in your own language. It's not that you have to mug up all these things. Okay, it's just whatever is thing coming, I mean whatever sentence I am framing now, I am telling that. It's not that I mugged up and I am saying. Okay, volume of any gas is inversely proportional to the pressure of the gas, comma, provided the temperature and number of moles, provided the temperature and the number of moles of the gases or of the gas kept constant. Full stop. Next line, right? Mathematically we can write. What can we write mathematically? We can write it like this, right? V proportional to 1 by P. Yes? Don't forget to write this. If you don't write this, it is useless. At constant N and T. Right? If you don't write this, Boyle's law is not completed. Please. Okay? Therefore, just little bit mathematical derivation will do. Therefore, V is equal to some constant we can write. K divided by P. Yes? Right? Where K is the proportionality constant. Okay? Therefore, PV equal to K. Therefore, so PV equal to K means what? The product of pressure and volume at any condition is constant. So suppose at this condition the pressure is P1, volume is V1. When the condition is changed, the pressure is changed from P1 to P2, the volume is also changed from V1 to V2. But P1, V1 should be equal to P2, V2. If it changes to P3, V3, that will be equal provided the temperature and the number of moles are constant. Okay? Therefore, P1, V1 equal to P2, V2 equal to etc. Okay? Fine? Okay? Right. Graphically, this law can be expressed as graphically. This law can be expressed as, see, three ways we can draw graphically. Very simple, and you must understand it. Don't remember it. Repeatedly I am saying, don't remember it. These questions are very common questions. Okay. First, the relationship between P and V. You tell me what happens if we increase P. What happens to V? Decreases. V increases, P decreases. Okay. So V is less, volume is less, pressure is very high. Pressure is very high. As the volume increases, the pressure decreases. But this decrease is not uniform. It does not decrease uniformly. Okay. So it decreases like this. Like this, and after a certain time, obviously it will become constant. It is not going to change. So this is the variation of P and V, and this curve is called PV curve. We call it PV curve. Okay. Now tell me, so that is one of the way by which we can represent the Boyle's law graphically. Draw it. Okay. The first one. That is first one. P versus V curve. Okay. PV curve. The next one, if I now tell you, is this done? Done, right? Everybody has done it. Okay. The next one, if I tell you to draw P versus 1 by V, you see your equation and tell me, if P increases, what will happen to 1 by V? 1 by V will also increase. If P increases, 1 by V will also increase. When P is 0, 1 by V is also 0. Now this is happening very uniformly, proportional, right? Okay. So the nature of the graph will be like this, and it will pass obviously through origin. Okay, because P is 0 means 1 by V is also 0. Yes, simple. If you understand the physical concept, it's not that you have to remember the graphs. No, this we are not drawing anything, we are understanding it. Okay, and the third way of representation of the same law, third way of representation. So ये दोनों हो गया, ठीक है? The third way, suppose PV versus V, or somewhere you can say PV versus P. अगर आप P increase करेंगे, तो PV का क्या होगा? सोच के बता. देख के बता. अगर PV increase करेगा, P increase करेगा, what will happen to PV?
Constant.
PV is constant, right? P increase करेगा तो V decrease करेगा, लेकिन PV will remain constant, right? अगर V increase करेगा तो क्या होगा?
P decrease होगा.
PV का क्या होगा?
Constant.
It will remain constant. PV under any condition, if the temperature and the number of moles is constant, PV will remain constant, right? So PV does not vary with V. PV does not vary with P, right? Whatever is the value of PV, suppose this is the value of PV at V is equal to 0. If it is the value, then it will remain only. It will remain as constant. Yes, did you understand that? Okay. So these are the three ways of graphical representation of what? Graphical representation of the Boyle's law. Okay.